All right. Hey, everyone. So we are covering 10.7 here in this video, partial fraction decomposition. This might actually be kind of long, so grab that popcorn. Okay, so 10.7, partial fraction decomposition. Okay, so let's recall adding rational functions. So let's just recall that from earlier. I think test 1 covered it, where you had something like this, 2 over x minus 3, and you had to add -1 over x plus 2. Do you remember doing this? You have to find the LCD. The LCD here is x minus 3x plus 2. Okay, and then you would multiply that first fraction by x plus 2 over x plus 2, and the other one by x minus 3 over x minus 3. And then when you add these, you would get x plus 7 all over x squared minus x minus 6. Okay, so that's what we had learned before. So what we're doing now is we're actually going backwards. Okay, so now what we're doing is you will be given x plus 7 over x squared minus x minus 6. And you will need to find the fractions that you combined to get this answer, x plus 7 over x squared minus x minus 6. Okay, and we can see from the problem above that, okay, well, the answer is 2 over x minus 3 plus -1 over x plus 2. That's what you added together to get that answer. Okay, so coming up with these fractions is going to be what we look at today. Okay. All right. So let's talk about the process for finding these fractions. And that's what we call the partial fraction decomposition. Okay, so the process. So the first thing you want to do is factor the denominator. Okay, so like in that above problem, x squared minus x minus 6, you would want to factor that. Okay. And then you determine the number of fractions you're going to need. And I'll explain how you do that. Okay, so we see in the above example, we added 2 fractions to get that answer. Okay, and then we're going to set up the fractions accordingly. Okay, so when you set up these fractions, so this is going to be based on the factors of the denominator. So that's why that first step, factor the denominator. Okay, so we're going to, it's based on the factors of denominator. Okay, and then it will also be based on so what's going to happen is over here, see how we have the 2 over x minus 3 plus the -1 over x plus 2? Okay, so you'll notice that the x minus 3 and the x plus 2, okay, so those come from the factors of x squared minus x minus 6. Okay, and so what's going to happen here is we're going to be solving for the numerators. We're going to try to figure out, oh, what's the numerator of each of those fractions? So in this case, it's a 2 and a -1. Okay, so once you set up your fractions, your numerators will have variables. And this is what we will be solving for. Okay. All right. And so once you set up your fractions, okay, the way you go about solving for these variables in the numerator is first you go ahead and you add and subtract your fractions as usual. Get the common denominator, multiply, and then add like terms. Okay. So you're going to do that. And then once you have the answer there, then you're going to set up a system of equations and solve. And if you remember, we started this this chapter 10. We started this chapter with solving systems. So here is just another example of where we need to be able to know how to solve systems of equations so that we could find the partial fraction decomposition. And why would we want to do that? Later on, if you do decide to take calculus, when you find there's going to be this thing called integration, which finds the area under a curve, or it could be volume. Okay, so, and what happens is sometimes it's easier to find the integral of these two fractions right over here rather than this one. Okay, and so that's why we want to be able to break it down. Okay, so you're going to set up your system of equations and solve. Okay, so these steps will make a little more sense once you see some examples done. Okay, so, but before we start working on some examples, let's talk about this part, because this part right here, setting up the fractions, step 3, setting up the fractions accordingly. Okay, so we have some different cases. Okay, so let's talk about them. So setting up fractions accordingly. Okay, so what does that mean and how do we do it, right? Okay, all right, so case 1. Okay, so suppose that you do factor out that denominator, okay, and you end up with distinct linear factors, meaning that all the factors in the denominator are different, okay, and none of them repeat, okay? So distinct linear factors. Okay, so for example, the one above, okay, we factor it out, and it turns out we get x minus 3 times x plus 2. Okay, so here we have two factors. They're different from each other. They don't repeat. Okay, so you have x minus 3 and you have x plus 2, as opposed to x minus 3 times x minus 3. That's repeating, right? Here, they're not repeating and they're linear, as opposed to quadratic. We don't see x squared, right? We don't see x squared minus 3. It's strictly x to the first power. So these factors are linear and they're not repeating. Okay. So when you have this case, then your setup is going to be one fraction for the x minus 3 and another fraction for the x plus 2. Okay. And it doesn't really matter what you call the letter in the numerator. If you want to use M and P, that's fine. Just keep track of what letter is above the x minus 3 and what letter is above the x plus 2. Okay, so that's how you would set it up. Okay, so that's the case 1. Okay, case 2, you have repeated linear factors. So here you don't have anything repeating. You have x minus 3, x plus 2. So let's take a look at what happens when you have repeated linear factors. Okay, so for example, Okay, suppose that you have, suppose you have this one, 2x minus 3 over x minus 1, and suppose that it repeats 3 times, okay? So what happens here is when you have repeating factors, make sure you use the exponent to represent that repetition, okay? Because what's going to happen is you're going to have 1 for that factor to the first power. You're going to have 1 for that same factor to the second power, and you're going to have 1 for that same factor to the third power. So you have 1 for every level up to that highest power, okay? So that's how you would set up that one, okay? 1 for each level until you get to power 3, okay? Another example, suppose that you have this. Suppose that you have 5x squared plus 20x plus 6 all over x times x plus 1 squared. Okay, so we have 2 factors here. One does not repeat and the other one does repeat. Okay, so when we set up our fractions, we're going to have 1 for the one that does not repeat. And then we're going to have 1 for x plus 1 to the first power and x plus 1 to the second power. Okay, so that would be the setup for that case. Okay, and let's take a look at one more. Suppose that you have this one, 4x squared plus 2x minus 1 all over x squared times x plus 1. Okay, so very similar to the one just before this, you have one factor that repeats, and you have one factor that does not repeat. Okay, so let's start with that x squared. So you're going to have 1 for x to the first, and then you're going to have 1 for x squared. Okay, and then the other factor, x plus 1, we'll need a fraction for that one. Okay. Okay, so when you have these repeated linear factors, just make sure you do one for every level until you reach that power. So if it's like this one over here, x minus 1 cubed, you're going to have 1 for first power, second power, and third power. Okay. All right. Case 3. And I'm going to come back to this last example right here with that x squared. Okay. I want to point something out there, but not just yet. Okay, so case 3. Case 3 is if you have irreducible quadratic factors. Okay, irreducible means not factorable. Okay, so irreducible quadratic factors. Quadratic meaning like x squared. Okay, so for example, if you have something like this. Okay, so you have some numerator. So far the numerator is not really playing an important role as far as our setup goes. So our setup is mainly based on the factors in the denominator. Okay, suppose I have that factor, and suppose that I have this factor, x squared plus 4. Okay, so here, make sure you see the difference. Okay, so here you have a linear factor x, and then you have a quadratic for the other factor. That's x squared plus 4. If you take a look at all of these other ones, that's x plus 1, that's x plus 1, that's x minus 1. None of those are quadratic. That's x minus 3 and x plus 2. All of those are linear. Okay, they're all x to the first power inside the parentheses, right? X to the first power minus 3, x to the first power plus 2, x to the first power minus 1, and then here x to the first power plus 1, x to the first power plus 1, okay? But when we look at this one has x squared plus 4, okay? So that's a quadratic. And when you have a quadratic factor, then you have a different setup, okay? The linear factor x, that will remain the same. So you'll have one fraction for that one, okay? Now for the quadratic, so the quadratic is x squared plus 4, okay? So that's a quadratic factor. That's not a repeating factor, okay? If I had a 3 on the outside, now it's a repeating factor, okay? It repeats 3 times, okay? But this is not a repeating factor. That's a degree 2. That's a quadratic factor, okay? And when you have a quadratic factor, all of them have been linear so far, and so we've been using just a letter for the numerator. But when you have a quadratic factor, then the numerator is not going to be just a letter like b. It's actually going to be a linear equation, bx plus c. You're used to seeing that as y equals mx plus b. Okay, so let's just keep the letters in order. So it's bx plus c. Okay, so when you have that quadratic factor, then in the numerator, you're going to have more than just a letter like a. You're going to have bx plus c. Okay. All right. So now let's work out some examples. So expect one problem to take up a lot of room. All right, so let's start with this first one. Write the partial fraction decomposition for x plus 7 over x squared minus x minus 6. Okay? All right, so I'm going to bring it down here. So the first thing I need to do is factor out that denominator. Okay? So we'll leave that numerator alone, and let's go ahead and factor out that denominator. So it's going to be x times x to make x squared. We need -6, so the signs will be different. And it's going to be, looks like 3 and 2. And it looks like it will be -3 and +2 to get that -1 in the middle. Okay, so now that we have the denominator factored out, we can determine our setup. So we know our setup is going to be a over x plus 2 plus b over x minus 3. Okay, that's going to be our setup, and we're going to need to solve for a and b. Okay, so if you notice all of these, the variables that we have to solve for are a, b, c. Okay, and they're all in the numerator. So we're trying to figure out the numerators. Okay, a, b, c, a, b, c. Okay, all right, so here we're going to try to figure out what a and b are. Okay, so the next step, if you look at the steps for the process, okay, so we have it set up. And so now we can go ahead and add these two fractions. Okay. So I'm going to bring those two fractions down here. A over x plus 2 plus b over x minus 3. Okay, so if you remember how to add rational functions, remember we first have to find the LCD, which is x plus 2, x minus 3. Okay, so that's my LCD. And so now I have to figure out what I need to multiply by. So that first fraction, I have x plus 2, but I don't have x minus 3. So I'm going to multiply this one by x minus 3 over x minus 3. The second fraction, b over x minus 3, that one, I have x minus 3, but I need x plus 2. Okay? All right. So let's go ahead and multiply those out. So I get ax minus 3a plus bx plus 2b. Okay, all over x plus 2, x minus 3. Okay, so now at this point, now what's going to happen is the denominator is going to kind of take a back seat, and now the numerator plays an important role. Okay, so here, what I'm going to do is I'm just going to go ahead and organize my terms here in the numerator. Okay, do you see how you have x terms there? An ax and a bx. I'm just going to kind of put them together. Okay, so I'm going to write it ax plus bx. And do you see how the other two terms, negative 3a and 2b, they don't have any x's? Okay, so I'm going to put those together. Okay, and you'll see why in a second. And our denominator, which is, like I said, taking a back seat. Okay, I'm going to organize this even more. Okay, and what I'm going to do is, do you see how right here? Okay, do you see right here how they have x in common? So I'm going to factor out the x. Okay, so I'm going to factor out the x, but instead of putting it out in the front, I'm going to put it over here. Okay, if I distribute this, I will still get that back, ax plus bx, right? Okay, and then over here, I'm just going to group these two, negative 3a plus 2b, and you'll see why in a second. Okay, over our denominator, which, like I said, is taking a back seat now. Okay, so now that I've grouped them, organized them in such a way that it kind of matches up here, let's take a look at the original problem. So the original problem has x plus 7, right, in the numerator, x plus 7 in the numerator. So that's what this should be equal to. So this here, this should be equal to, here, let me get my red pen. This here should be equal to 1x plus 7. Okay. Okay. So a plus b should be equal to 1. Do you see that? And negative 3a plus 2b should equal to 7. Okay. Because that was the original problem, x plus 7. Okay. So that should a plus b. So here's your system. Okay. So now here's your system that you'll need to solve. Okay. So all we're doing here, I'm gonna highlight this. Okay. All I'm doing here is this, a plus b should equal to 1. Okay. So that's what I'm going to write. That's my first equation in my system. Okay. So my first equation is that a plus b should equal to 1. Okay? My second equation, okay, is that this here, negative 3a plus 2b, should equal 7. Okay? So that's what I'm going to write down for my second equation. Okay? So negative 3a plus 2b should equal to 7. Okay? Because remember, this long fraction here that I got at the end is equivalent to that, which was equivalent to that, which was equivalent to that, which was equivalent to the problem that we started with, right? So if they're equivalent, then the coefficient for x, a plus b, should be equivalent to the coefficient of x in the original problem, 1. Okay, and the constant, the non-x part, negative 3a plus 2b, should be equivalent to the non-x part in the original problem, which is 7. Okay. All right, so let's go ahead and solve this system. Okay, so you can use substitution method or you can use elimination method. Okay, so it really doesn't matter which one. Okay, so I will use elimination method. Okay, so I'm going to multiply that top equation by 3. Okay, so let me use a different color. So I'm going to multiply this by 3. Okay, and so then I end up with these. I end up with 3a plus 3b equals 3. And I'll bring down that second one, negative 3a plus 2b equals 7. Okay, and my a's are going to eliminate. Okay, when I add these equations together, the 3a's cancel out. I'm left with 5b equals 10. Okay, so b equals 2. Okay, so that's one of my answers for my numerator. Okay, so I'm going to go ahead and use that first equation, a plus b equals 1, to solve for a. So a plus 2 equals 1. So a equals negative 1. Okay. All right, so I know my a and I know my b. So then going all the way back up here to these partial fractions, okay, now I know what they are because now I know what a is and I know what b is. Okay, so we said that a is negative 1. So then my final answer here is going to be negative 1 over x plus 2. And b is, we said b equals 2. So then my second fraction is going to be 2 over x minus 3. So this here, these are the partial fractions that you combine to get x plus 7 over x squared minus x minus 6. And if you don't believe me, you can go ahead and add those two fractions together, work it all out, and you should get x plus 7 over x squared minus x minus 6. Okay? All right, so let's kind of take a look at what we did here. Okay, so the first thing we did over here, okay, so the first thing we did was factor that denominator. Okay, we have two linear factors, so we're going to have one fraction for the x plus 2, one fraction for the x minus 3. We just need letters here because these are linear, not quadratic. Remember, we do the bx plus c business. We do that when these are quadratic. These are not quadratic. These are degree 1. Okay. All right, so we set it up. Once we set it up, then we go ahead and add them as usual. Okay. And then, so I distribute the a, distribute the b, and I get these 4 terms. And then all I do here is I rearrange them. I reorganize them. I put the x terms together, and I put the non-x terms together. And when I do that, I just go ahead and I factor out the x. So it looks like this. So I can see that, oh, it's a plus b. That should equal this coefficient. And then I can see here, oh, it's negative 3a plus 2b. That should equal this coefficient. Where did I get this? This was the original problem. Look up here. 1x plus 7. Okay, so 1x plus 7, that's the numerator. Well, this is the numerator. So they should be equal to each other. So a plus b should equal to 1, because that's the coefficient of x. And negative 3a plus 2b should equal to 7, because that's the constant. Okay, so that becomes my system. A plus b equals 1. That's my first equation. Negative 3a plus 2b equals 7. That's my second equation. Okay, I solve the system for a and b. And once I solve for a and b, then I substitute them in here to my partial fractions. Okay? All right, let's go ahead and try another one. Okay, so let's try this example here. Write the partial fraction decomposition. And let's do it for this one. X minus 2 over x squared plus 4x plus 3. Okay? All right. So again, the first thing you need to do is factor out that denominator. Okay? So let me bring the problem down here. All right, so let's factor out that denominator and set up our fractions. So here, factoring this out, xx plus plus looks like 3 and 1. Okay, so we have linear factors here. So we're going to have one fraction, a over x plus 3, and another fraction, b over x plus 1. Okay? And we're going to have to set up a system to solve for a and b. Okay? So let's go ahead and add those two fractions, a over x plus 3 and b over x plus 1. Okay, so I need my LCD. My LCD is going to be x plus 3, x plus 1. Okay, so the first fraction with the a, I'm going to multiply that one by x plus 1 over x plus 1. And the second fraction, b over x plus 1, I'm going to multiply that by x plus 3 over x plus 3. Okay. So now that gives me the same denominators, so I can actually add these together. Okay, so let's go ahead and distribute. So that's going to be ax plus a, and this is going to be bx plus 3b. Okay, all over x plus 3, x plus 1. Okay, and again, at this point now, your denominator takes a back seat, and it's all about setting up that numerator. Okay, so reorganizing the numerator so that the like terms are together. I'm going to put the ax and the bx together, and I'm going to put the a and the 3b together. X plus 3, x plus 1. Okay, and again, I'm going to factor out that x right here. I'm going to factor out x. Okay. Okay, so when I do that, I get a plus b here, and I get x on the outside. And then here, I'm just going to keep them together inside their own little grouping symbols. Okay, all over the denominator. Okay. All right, so now I can match these up. Okay, so let's take a look at the original problem. And what we're going to be doing is we're going to be looking for the coefficient for x and the constant. So let's see what we have. All right, so there's the original problem. We have 1x minus 2 for the numerator. 1x minus 2. Okay, so over here, this should be a 1x minus 2. Okay, so there are my equations for my system. A plus b should equal to 1, and a plus 3b should equal to negative 2. Okay, so let's set up our system. So a plus b equals 1. And a plus 3b equals negative 2. Okay. All right, so I'm going to use elimination method. So I will multiply that bottom one by negative 1. Okay. And when I do that, I'll get the a's to eliminate. Okay, so this is what we end up with. A plus b equals 1, and negative a minus 3b equals positive 2. Okay, so adding these two equations together, the a's cancel out, and I get negative 2b equals 3. Okay, so negative 2b equals 3. Okay, so solving for b equals negative 3 halves. Okay, so there's one answer. I need a, so I'll use that first equation. A plus b equals 1. Okay, so a plus b, which is minus 3 halves, equals 1. Okay, so solving for a, add 3 halves to both sides, and you get 5 halves. Okay, so a equals to 5 halves. So we have our a, we have our b, so we have our partial fractions. So let's go to the top to see what our partial fraction setup was like, so we know where to place these. Okay, so a is 5 halves, and b is negative 3 halves. Okay, so when we write this, we said a is 5 halves. And b is negative 3 halves. Okay, but that's messy looking, so don't leave it like that. Bring those bring those denominators in the numerator, those halves, bring that down. Okay, so it's going to be 5 over 2 times x plus 3. And you don't have to say plus negative 3. You can just say minus 3. And also bring that bring that down below. Okay. So this is how you're kind of expected to write the answer. Okay. So just like this. If WebAssign doesn't take that, then distribute the 2 to the x plus 3, distribute the 2 to the x plus 1, okay? But definitely don't leave it like this. Messy. Okay. All right. Okay. Very good. Let's take a look. And again, if you have that negative right here, then don't leave this plus. Bring that negative here to the subtraction, okay? Okay, let's take a look at another one. Write the partial fraction decomposition for 2x minus 3 over x minus 1 quantity squared. So we have a repeated linear. Okay. All right. So let me bring the problem down here. 2x minus 3 over x minus 1 quantity squared. Okay, so the denominator is already factored, and we see that it's a repeated linear. So this is the one where you have to have one for every single power until you get to 2. Okay, so we'll have a fraction for x minus 1, and then we'll also have one for x minus 1 squared. Okay, so one for x minus 1 and one for x minus 1 squared. Okay. All right, so there's our setup. So let's go ahead and add those fractions. So let's do the work down here. Okay, so a over x minus 1 plus b over x minus 1 squared. So I'm going to go ahead and add those. So my LCD is x minus 1 squared. Okay. All right, so my device is slowing down. Okay, so a over x minus 1, I need to multiply that by x minus 1 over x minus 1. B over x minus 1 squared, it already has the LCD, so I don't need to touch that one. Okay. All right, so let's go ahead and multiply this out. So I get ax minus a, and then the plus b, all over x minus 1 squared. Okay, and there's not much to organize in the numerator. I only have one term with x. Okay, so I only have one term with x. That's this right here. And then I have the rest of it there. So let me put that negative a plus b. Let me put that in parentheses, negative a plus b. Okay. All over my LCD. And that's just so I can match them up with the original numerator. Okay, so original numerator, let's take a look. Original numerator is 2x minus 3. Okay, 2x minus 3. So then over here, this should be 2x, and this should be minus 3. Okay. All right, so let's set up our system. So we're going to have a equals 2. Okay, a equals 2, and we can see that because a is the coefficient of x, 2 is the coefficient of x. Therefore, a must equal 2. Okay, and then we see that negative a plus b must equal negative 3. Okay, great. So here we already have a. Perfect. So now I'm just going to substitute that a value into the second equation. So that's negative 2 plus b equals negative 3. So negative 2 plus b equals negative 3. Okay, add 2 to both sides. So b equals negative 1. Okay, so a equals 2, b equals negative 1. We have our a, we have our b, so we have our partial fractions. Let's take a look at the very top here. Here they are. So a is 2, so that's going to be 2 over x minus 1, and b is negative 1, so I'm going to bring that subtraction here over x minus 1 quantity squared. Okay, so this here will be your answer. Those are your partial fractions. Okay, so thank goodness that was an easy one. Okay, so we have 2 more examples. Okay, I want to do one where we have a quadratic in the numerator. Make it a little more interesting. All right, so let's take a look at this one. Write the partial fraction decomposition for 5x squared plus 20x plus 6 all over x cubed plus 2x squared plus x. Okay. Again, it's all still the same concept. Okay, so we still need to factor out that denominator. Okay, so that's going to be, I'll factor out an x, and I'm left with x squared plus 2x plus 1. I can still factor that some more. 5x squared plus 20x plus 6. So I can factor out that denominator some more. That's going to be x, and that is actually going to be x plus 1 times x plus 1. Repeated. It's repeated, x plus 1 times x plus 1. So whenever it's repeated, you want to use your exponents to represent that repetition, okay? Because seeing it with that exponent will help you know how to set up your fractions. So we know we're going to need one for x, and we know we're going to have one for x plus 1 to the first power and another one for x plus 1 to the second power. So we have one for this and one for this. Okay. Again, these are still linear factors, so we just need letters in the numerator, a, b's, and c's. Okay. The last example, I'll show you one with a quadratic factor where we have to have that bx plus c in the top. Okay. All right. So we're going to have to add those three fractions together. A over x plus b over x plus 1 plus c over x plus 1 squared. Okay. All right, so we need our LCD. Okay, so our LCD is going to be, we need x, and we need x plus 1 squared. Okay, so x and x plus 1 squared. You always use the highest power of the factor. Okay, and we don't need another x plus 1. We just need x plus 1 squared, the higher power of the two. Okay, all right, so let's go ahead and figure out what we need. Okay, so this first fraction, a over x, we need x plus 1 squared. Okay, the second fraction, we need x, and we also need an extra x plus 1. Okay, and this last fraction, we need x. All right. Okay, so let's go ahead and multiply these out. Okay, so again, now our denominator takes a back seat. All right, so we get a times, that's going to give me x squared plus 2x plus 1. Okay, when you square a binomial. And then that middle part, I'll get bx squared plus bx. Okay, bx squared plus bx. And then that last one, we just get cx. Okay, all over our denominator, x plus 1 squared, which is taking a back seat right now. Okay. All right, I'm going to distribute that a. All right, so I get ax squared plus 2ax plus a. Okay, all I did was distribute that a. I'm going to bring the rest of the terms down. So bring down the plus bx squared plus bx plus, hold on a second, things are getting a little messy here. And slow. Okay, there we go. Plus bx plus cx, all over our denominator. Okay, so I'm going to organize. Okay, so I'm going to organize my numerator. We have a lot more terms now, so it's a little more interesting. Okay, so I'm going to put them in descending order. So I'm going to start with my x squared terms. Okay, so I have two terms here with x squared. I have the ax squared and the bx squared. Okay, so ax squared plus bx squared. So I'm going to put those together. All right, and then I'm going to put my x's together, and I have three of them. I have a 2ax, a bx, they're right here. Okay, so I have a 2ax, a bx, and a cx. So I'm going to put those three together. So 2ax plus bx plus cx. Okay, and then I'll put my no x term. And it looks like I only have this one. Yeah. Okay. So I'm going to put that one all by itself plus a all over the denominator x plus 1 squared. Okay. And here I'm going to go ahead and factor again. Factor out the x's. That way I can see what I have in the numerator. Okay. So here I'm going to factor out x squared Okay, so it'll be a plus b, parentheses, x squared. And then here, these three, I'm going to factor out x. Okay. Okay. And then that a, I'm just going to leave it by itself. Okay. All right, so let's see what we get. Come on. There it is. Okay. So I'm going to factor out that x squared, and I'll be left with a plus b. I'm going to factor out the x, so I get 2a plus b plus c inside the parentheses. Okay, so I get 2a plus b plus c, close parentheses, x. Okay, and then I have my a all by itself. All right, very good. All over my denominator x plus 1 squared. Okay, so now I have my numerator all nice and organized. So now I can match it up with the original problem. So I should have a coefficient for x squared, a coefficient for x, and a constant. So let's see what they are. Okay, there it is. Okay, 5x squared plus 20x plus 6. So the coefficient for x squared needs to be 5, the coefficient for x needs to be 20, and the constant needs to be 6. Okay, so 5, 20, and 6. Okay, let's go back down. So this needs to be 5x squared plus 20x plus 6. Okay, so now we can set up our equations. A plus b equals 5. That's this right here. A plus b equals 5. 2a plus b plus c equals 20. And a equals 6. That a equals 6 is going to be a nice little help. Okay, so here's our system. Okay, a plus b equals 5. That's our first one. 2a plus b plus c equals 20. 2a plus b plus c equals 20. And then the last one, a equals 6. Okay, so we already have one answer. Excellent. So I'm going to take that and I'm going to plug that into the first equation. And back substitute, I guess. Okay, and so here I'm going to get 6 plus b equals 5. Okay, so 6 plus b equals 5. So b equals -1. Okay, so that's another one. And now I'm going to plug these into that second equation. So 2 times 6 minus 1 plus c equals 20. Okay, all I'm doing is plugging a and b into that second equation there. Okay, so that's 12 minus 1 is 11. Okay, so c equals 9. Okay, so c equals 9. So I have all three of my letters, a, b, and c. So now I can determine my partial fractions. So let's go up. Okay, up, up, up. All right, so here we go. So my answer here, a is 6, so 6 over x. B is -1, so -1 over x plus 1. And c was 9, I believe. C is 9. Okay, so plus 9 over x plus 1 squared. Okay? So these would be your partial fractions. Okay, so these are the fractions you add together to get 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. Okay, so if you add these all together, you would end up getting that. Okay, so we're working backwards now. Okay, all right. We do have one more example. One where you have a quadratic. So we're going to have a linear, a bx plus c situation. Okay. But at least the system is not too long to solve. Okay. Let me get my black ink back. So right now, the thing that's kind of suck is that my device is slowing down. Okay. All right, so here, write the partial fraction decomposition for 2x squared minus x plus 4 over x cubed plus 4x. Okay. All right, so we need to factor out that denominator so that we can figure out our setup of our fractions. Okay, so right now the numerator is not doing much. I'm going to factor out an x, and I have x squared plus 4 left in parentheses, and x squared plus 4 does not factor. So we have a quadratic factor in this case. So we're going to have one fraction for the x, and we're going to have another fraction for the x squared plus 4. And remember, when you have a quadratic factor, you have to have a linear expression for the top. So this is that bx plus c situation. Okay, so bx plus c. So we still need to solve for a, b, and c. Okay. All right, so let's bring those two fractions down here. Okay, so a over x plus bx plus c over x squared plus 4. Let's add these. The LCD is going to be x squared plus 4. Okay, so that's my LCD. Okay, so I need to multiply this by x squared plus 4 over x squared plus 4. I need to multiply this one by x over x. Okay, and should have been doing this the whole time, but I wasn't. Maybe keep those all in parentheses so you remember to distribute. Okay, so I need to do that. All right, so let's distribute the a. So I get ax squared plus 4a. And let's distribute that x. So I get bx squared plus cx. Okay. All over my denominator, which will now take a back seat. So now it's all about that numerator, organizing it, and then matching it with the original one. Okay. All right, so let's take a look at what we have here. So let's reorganize it so that we have the x squares together. Okay, and so I get the ax squared plus the bx squared. and then the cx all by itself, and then the 4a all by itself, okay? All over x squared plus 4, okay? Factor out that x squared. So I get in parentheses a plus b times x squared, plus that c is all by itself, plus cx, and that 4a is by itself as well. Okay, all over x squared plus 4. Okay, so now that we have our numerator all organized, okay, so let's match it up with the original. Let's take a look. All right, so there's the original. 2x squared minus x plus 4. 2x squared minus x plus 4. So over here, this needs to be 2x squared. 2x squared. This needs to be minus 1x. And this needs to be plus 4. Okay, so my system, let's go ahead and set that up. A plus b equals 2. Okay, right? I get it from right here. A plus b equals 2. C equals -1. 4a equals 4. Nice, easy system. A plus b equals 2. C equals -1. That will be helpful. And 4a equals 4. And that will be easy as well. Okay, so we have one of our answers now. C equals -1. There are no other c's, so that's it for that. Over here, 4a equals 4. So I can solve for a equals 1. Okay, so we have our a, we have our c. So let's solve for b. Okay, so I can solve for b using that first one and substituting 1 for a. So over here, I'll write 1 plus b equals 2. 1 plus b equals 2. Okay, because a equals 1. So then b equals 1. Okay, so I have my 3 variables now. I got my a, my b, my c. So I can go back to the very beginning of the problem and figure out my partial fractions. So if I take a look up here, so then here, a is 1. So we get 1 over x. B is 1 and c is -1. Okay, so it's 1 over x plus b is 1, so that's just 1x, plus c, that's -1, over x squared plus 4. Okay, so all we did was plug in for a, b, and c. So these are the partial fractions that you add together to get that original problem at 2x squared minus x plus 4 over x cubed plus 4x. Okay, so again, you just plug in for a, b, and c. A is 1, so that's 1. B is 1, so it's 1x. C is -1, so it's -1. Okay? All right, so that is it. We finished. Okay, so keep up with the homework. We are almost there. We are almost done with the semester. And keep in mind, last day to drop is this Friday. Okay.